Welcome to lecture 21 of part 1. Someone will tell, this already was there last time. Yes, some extra information for you. See, just to make a note. First I will tell something here. Because some space is there. Or make a note. See, first of all, everything slowly I will tell. When you want a moment of a force about any point, first I told you, it is force multiplied by perpendicular distance from that point to line of action of the force. See, if a point is here, for a vertical force, it is horizontal distance. For a horizontal force, it is vertical distance. Therefore, if the force is horizontal or vertical, there is absolutely no problem. Directly you get the answer. You can find moment very, very easily. Okay, next. By chance, if the force is inclined, then if you see, suppose inclined force, if you want moment about any point, from that point to the line of action of the force, you have to drop a perpendicular, say h. Then moment equal to that force into perpendicular distance h. This I already told so many times earlier. Last time examples over, everything over. Now, but one thing, if the force is inclined, instead of struggling mathematically, not struggling actually, but some people will tell us struggling, okay, mathematically, to find that perpendicular distance h, what you can do is, if the force is inclined, you can resolve into horizontal component and vertical component. This also I covered last time. Then once again becomes easier. But still remember, basic approach, I am discussing basic approach now. Basic approach is inclined force is there means force into perpendicular distance. So proceed further with that one. Now, there are two cases are there. One of the case, see, suppose you want moment about this point. I will tell A point because throughout I am telling A so far. A, okay. You imagine one line here. Imagine one line here. Okay. I think it is within the camera. I have taken care. Yes, within the camera. Okay. One vertical line, one horizontal line. Now, if the inclined force is passing somewhere here, or if you know the point where inclined force cuts the vertical line through A, if you know that point, or see, if the inclined force is this way, you know a point where inclined force cuts the horizontal line. So from A, you imagine a vertical line. In that line, you should know a point where the inclined force will cut, or draw a horizontal line. Somewhere in that line, if you know the point where inclined force cuts that line, then finding moment by basic approach, that is P into H, is very, very simple. See, all you have to do is from here, draw perpendicular here. Perpendicular. Or from here, if you want moment about of this force, draw perpendicular here. Then H. You can find this H very, very easily. No, see, like last time, see, I extended the line. So many things were there last time. So there is absolutely no problem. Very easily. Or furthermore easy, some will tell, sir, instead of struggling that way, you can resolve. Okay, resolution is always there. That is the ultimate happy case. But still, if you want a basic concept, see, remember about which you want moment. If through that point, if you draw a vertical line, if you know the point where the force cuts that line, or if you draw a horizontal line, and if you know the point where the inclined force cuts that line, then calculation of H is very, very simple. It will come second round now. It will come right here. This will come little later. This will come little later. I will tell you now. Little later. Write this one. Okay. Now, but right here. But But, right here, but if you want moment about a point, suppose you draw a vertical line here, horizontal line here, okay. Suppose the inclined force is somewhere here, means it is, see, then, see, and that point, where that known point, see, there is always a known point for any force. One point is known for it. This is a known point. If you join it to A, it is not a horizontal line or vertical line, then finding perpendicular needs some extra calculation. Finding perpendicular needs some extra calculations. So I told you, if the inclined force cuts a vertical line point, cuts a known point in a vertical line passing through A means about which you want moment, or a horizontal line passing through A, very easy. It will come second round now. It will come after this is over. It will come now. I am covering everything systematically. But if that point where force is passing, actually there are infinite points are there. If that point where force is passing, if it is not connected to A either by a horizontal line or vertical line, yes, see, it is connected by inclined line, then finding H has little trigonometric calculation. That we already covered last time. Okay, now, but of course there also, remember, finally resolution is the best one. You know last time. Okay, now do one thing. This much you write. Now write here, class, once again. Part 1, lecture 21. As per basic definition, last time we found moment by force into perpendicular distance. Resolution is last option, actually last and best option. That is ultimate easy option. Okay, now I am continuing with the basic approach. Write everything what I am going to tell. Everything what I am going to tell. If an inclined force is given, see, I told you where, see, the inclined force 80 Newton is passing through C, that point, known point C, when you consider A, the line joining them is neither horizontal nor vertical. See, both the question. So therefore, question was, it is the same question which is considered last time. Question is, find moment of the given 80 Newton force about A. Here also same thing, 200, 160, 160. Here angle is 20 degrees, there 60 degrees. I remember, I noted down. 60 correct? Yes, 60 correct. I remember 60. Over. Now, what happened is, you write here. Last class, he solved fully this question. Moment equal to 80 into H. H, moment about A equal to force 80 into somewhere, perpendicular distance H. Here also, moment about A equal to 80 into perpendicular H. Okay. Clockwise, anti-clockwise, you decide later, once you know which side the perpendicular will come. Now, this ABC, this is 160, this is 200. First, you found out this theta. You find this theta, because you should know when you consider AC, will it come this side or this side? See, if the force comes this, see, if it comes stiff, if it comes this way, see here, perpendicular is on, see, then perpendicular will be on this side. Whereas if it is see, if it is this way, then from A, perpendicular is this side. This is actually already over last time. This also explained. Now, write one note. Already this question is solved. Last time what he has done is, see right here, question 1, 70 degrees, 20 degrees, 70 degrees, 70 degrees. He extended the line because this angle is 20, this is 70 degrees, see, red color I will use, 70 degrees. C to A is making how much? 51 point, see, this is 51. So it will come this way, 70. He extended it. Let it cut the BA, this BA line extended at D. Then from A, draw perpendicular. First, he found B to D. How? Using this triangle. See? Using this right angle triangle, he found B to D, which came 439.5964. I am not writing because why? It is already over last time. I am repeating. Then he found A to D. How? B to D, you got 439 point something. B to A is known, 200. So remaining how much? We got 239.5964. Then he used once again trigonometry for the small triangle, which one? ADE, again right angle triangle. He found the value of H. H came 81.9468 millimeter. Therefore, the moment is 80 into H came 6555.744 Newton millimeter. This was solution last time. Okay, now second question, what happened? This is, see, if it is 60 degrees, this is 30 degrees. See, if we join C to A, it is 51 degrees. This is 51 degrees. So your 30 degree will come this way. So it will come here, cut the line somewhere here, then extend here. From A, if you draw perpendicular, now also you require H value. He first found B to D by using which one? This triangle. All done last time. Once he got, BD got, then he got B to D. B to A is already known. How much? 200. From 200, he subtracted B to D. He got A to D. 107. He got means I got. Actually, you should write I got, because if you solve 107.624, once I get that one, use that small triangle, he got H equal to 93.2051. Then he got moment 7456.406. But this time, see, it is about A, anti-clockwise. He got the answer. Okay, right. Now doubt will come. Someone will ask, sir, it is very clearly told last time. Why you are telling same thing again and again? Maybe you want to increase one number of class? Surely no. I have got a marathon work. Who want to increase number of classes? But teacher's instinct. Anything to be told, I tell. I want each and everything in mechanics, SOM and SA at right now, RCCT later, etc. later. Perfect knowledge. With no mistake, I told you. No technical mistake. Calculation mistake, spelling mistake, all okay. Now, what happened is, on the board, today I wrote same class 21, I prepared a question. See, I prepared a question here, where this is A, I wrote one force here and one force here. I want moment of these two forces about A. Now, observe here, oh, this is not like last time. Here, this inclined force is the known point there is vertically connected to A, and for this inclined force, the known point there is horizontally connected to A. Therefore, work is easier. Work is easier. So I am taking today. Then suddenly I thought, I don't know why, as I wrote the question here, suddenly it came to my mind. It came to my mind, right? It came to his mind. Do you have to struggle this extension, theta, this distance, this one minus that one, required all? See, actually, such cases I don't get anywhere except in engineering mechanics. That too, so earlier I was teaching for students. Students all, I will tell resolve. I will tell them resolve. They are happy. I won't go for all this because limitations are there. For real technical knowledge I am giving now. Therefore, suddenly it came to my mind. Why should this is, can I eliminate this all? See, can I eliminate all this, extend the line, this one, that triangle, eliminate? No, see, when I can do this one so easily, I think if I try something, I may get. I will tell frankly and honestly with you, I looked at this diagram. This diagram was not there. This diagram was not there in the board. I roughly took a rough sketch of yesterday's question. I saw here. This diagram, light line I wrote. I looked here, suddenly realized, oh yes, this also can be done very easily. This struggling all not required. See, answer is correct. It is not wrong. Answer is correct. You can do very easily. It never, actually, don't tell that, oh, he is not knowing mathematics. Not that way. Because I never come across these things. Because usually you resolve it, correct? Any practical knowledge all, we resolve. So suddenly I thought, I think last time, yesterday's class, I told so much struggling I first thought students will have some difficulty to understand their struggle. Why don't I try something simple? As I looked at the diagram here and here, suddenly I got, yes, we can do it very easily. So that I will tell. So now first I will do one thing. Before going here, first I will tell previous, right here. Therefore, previous class, see this is a previous class question 1, this also previous class question 2. He will very fast, I will give the answer. Which one? Not resolution. Resolution means both are same. That finding H for previous class 2 questions, how much the struggling or trigonometric calculation involved can be drastically reduced. Easily you get the answer like this only. See, almost like this only. Very easily you get. So that if I explain that one in future, if anybody wants to find moment by basic concept of force into H perpendicular distance, if the force is inclined, whether it is connected to the point A with the vertical line or horizontal line or randomly somewhere, he can fluently do it. So I decided it. Now what I will do is, see, last time right here, he got H for first question, H for question 1, H he got, how much I got? 8 question 1, he got H equal to 81.9468 millimeter. And for question 2, he got H equal to 93.2051. Okay, now it is sufficient if I get this H by easy method. Then same thing, moment equal to force into H. I will remove everything now. I write here H, easiest way to find H for this question, easiest way to find H for this question. Then I will take up the next important part, that is when they are horizontally and vertically connected, that not point, that known point. Okay. I already wrote to save the time. See, now question is there. How to find H is important. Go there. See, BC is 160, 200. You should first find this angle. That is tan theta equal to 200 divided by 160. You already know it. I won't waste time now. Or write if you want. Tan theta equal to 200 by 160, 51.34. Okay, everybody. How I got? Tan inverse of 200 by 160. Okay, we got angle at 1. Now do one thing. Do an extra calculation. Also find this length, AC length. This is never got last time. That somebody in the high school will get it. Root of 200 square plus 160 square. It will come 256.1250 millimeter. Okay, so therefore in the question, whatever angle given, don't see the question. Don't see the force. This point you join here, get this length and get this angle. Okay, now see here. Put one scale. Now come back here. Now come here. See. A point is here. B point is here. C is here. Your force is making 20 degree with vertical. No, you should write with horizontal because this angle is horizontal angle. Therefore, this is 70 degrees. See here. C to A, this angle is theta. We already know 51.3402. But this is 70 degrees. Means if it is 70 degrees here, see, this is 70 means what? This fully 70. That much I should not explain. If this is 70, see, this is 70. Therefore, alpha equal to 70 means 70 minus theta. 70 minus theta, it will come 18.6598 degrees. This is again high school level mathematics. See, if it is 70, see this fully 70. I should not write first of all. See, this fully 70. So subtract theta, you get alpha. That's all. Now, happily, see from A right here, draw perpendicular H to this line of action. Let it be A dash point. Now, consider this triangle. See, this is right angle. So, sine alpha equal to H. See, this is 90 degrees. So this AC is the hypotenuse. So sine of this small angle alpha. See, this is alpha. I wrote very clearly. This is your alpha. Okay. Sine alpha equal to H divided by AC. Alpha is 18.6598 degrees. AC is 256.1250. You get H equal to 81.9468 millimeters. See here. Oh, right. Oh, so easy. Some will tell, sir, then why you told last time that way? Last time I wanted the point will come here. I extended and got the point. Then today suddenly I realized, see, this is not any technical mistake. It is a easy approach, further made simple, that's all. Further made simple. This I do, sometime I do it. But sometime I will tell, I was knowing it. Today I will not tell. I am always honest. Sometime I will tell, see, I made lengthy solution deliberately, but I know that it can be solved easily. This I came to know just today only. Today means what? Not a big issue, because I never come across this one so far. Suddenly idea flashed to me. Yes, ideas will always flash. Therefore, you can get this way. Oh, now see. Come to this question. Once again, same. Even for this question also, first come here. Why? First come here. See, same 160, same 200. So if you join same point, only thing is here force is 80 at 20 degrees, here 80 at 60 degrees. That is the only change. So once again, write this one. Again, get theta and get AC. Okay, then come outside. Now come to easy approach. See, once again I put here now. This is your point A. This is your point C. This is B. Okay, 1 minute now. See. This length is not required, no? Okay, this A. See here. This is 60 degree angle. So your red color force is this way. 80 Newton. They told 60 degrees vertical, but you write the angle with horizontal. Why? So that, because this is with horizontal theta, 60. Okay, now extend this line. See here. This, if I join here, that angle comes to 51.34. This is only 30 degrees. Therefore, the line will come somewhere here. That is quite easier. See. This is the extension of the force. So from A, if you draw perpendicular, your perpendicular will come here this way. Sorry, it should look like perpendicular. Okay. Okay. From A, draw perpendicular A dash. Perpendicular A dash. Now also do one thing. Like last time, this line is required. Okay. Now, see, this is 30 degree means this is 30 degrees. Guaranteed. 30 degrees. And this full angle is already known. How much? 51.3402 degrees. So, find this angle. I will call this as alpha. But last time, see, alpha was 70 minus theta. Now alpha is theta minus 7. Theta minus how much? This is 30 degrees here, 60 degrees. Last time, see, 70, correct. This is 30 degrees, this is also 30 degrees. So alpha equal to theta minus, not theta. What is theta? Correct. Theta, what is theta here? See, this full is theta minus 30. 30 equal to. Last time, see, it is 70 minus theta. Now it is theta minus 70, that way. Or actually 70 minus theta is here theta minus 30, because you can make out. That much I should not explain. See, once again go through. Equal to theta is already known. How much? 51.3402 degrees. You should know that one. Last time that angle was coming further this side. So 70 minus theta. Now that angle is coming inside. So theta minus what? 30. You observe high school math, not high school. Nowadays in primary school also there. Why you want calculator? Theta is 51 means it is 21.3402 degrees. Okay. Now over. Happily consider this triangle. See? this triangle. Triangle A dash C, which is right angle triangle. This is perpendicular. Okay. Right here. Sine alpha equal to this is perpendicular is H divided by C. Sine alpha equal to this is H. For this triangle, this is 90 degrees. So hypotenuse is AC. H divided by AC. Alpha is known for you, 21.3402. AC is already calculated to 256.1250. Therefore, you get the value of H now also. It will come same as last time. It has to come. I should not calculate first of all. Okay. 256.1250 into sine of 21.3402. If answer is not coming, how much? If answer is not coming, I am going to break this calculator. 93.2051. Oh, yes. 93. See, but I want to break the calculator. If answer is not coming, I will check the calculation once again. That is for fun, I will tell. Once it happened in long back class. Calculation mistake was there. I told if answer is not telling, calculator I am going to break. But answer did not come. I took the calculator and about to this way. Someone cried there, "Sir, my calculator, sir, it is not my calculator." I told this way. I told no. I applied very small moment, 0.001 Newton meter. So no bending, don't worry. Some calculation, we will check once again. Technical mistake means I will break the calculator. Such calculation, if answer not telling, I will check once again. Why? Human nature. Okay. Now, right here. Now, I will continue for the most powerful one. See, when the 2 points are connected. That is the most popular case in roof trusses or pin joint frames when you do method of section. Okay. I will make ready for that. Now start question number 3. Make a note, very, very important. This question is very important, especially for pin jointed plane frames when you analyze by method of sections. Why you worry at that time? Or you can tell. See, question is find algebraic sum of moments of given force system about A and C. Why I told A and C? Because I'll tell the reason why A and C. See, A is here. If I draw a vertical line here, this force cuts that line at a known point. If I draw a horizontal line here, this force cuts that line at a known point. But if the force is somewhere here, then no. Then the previous question is applicable. Then what you do? You require the inclined length, etc. We struggled last time. Usually we won't get it. So that's why this question is important. A and C. Now again C also. Why? When you take C, if you draw a horizontal line through C, this force cuts at a known point here. If you draw a vertical line here, this force cuts. Okay. But if I want about some A and C, suppose I want about which point? A and C I want. If I want about B, problem. Why? See, this force is not cutting this line or this line, not a problem. Then you require the joining of the line, etc. You have to do it. Find the angle, then some construction is there. I am going for most important case, that is when the inclined force cuts a known point in the vertical line or a known point in the horizontal line through that point about which moment is required. See, moment about A required, vertical line cuts here, horizontal line cuts here. Moment about C required, horizontal line cuts here, vertical line cuts here. Start. First, let us first find moment about A. Okay, see, A we will do first. Class. To find moment about A, remember we are finding by basic approach. By basic approach. Basic means force, but you should write it, force multiplied by perpendicular distance. Someone will tell, sir, resolution, wait. That is always there. Easy option is always there. First, be prepared for the difficult case. Understand everything. See, understanding concept will give you tremendous pleasure if you really study. See, start. To get moment about A, we need perpendicular distance from A to this line of action and A to this line of action. So from A, draw perpendicular to line of action of 200 and also draw perpendicular to line of action of 450, H1, H2. H1 is for this force, H2 is for that force. See, A is here. Our point is A. Your 200 force is here. Extend it. Perpendicular H1. 450 is here. See, red. I am making force red color. 450 here. H2. Now, this angle 30 degrees. So this is 30, this is 60, this is 30 here. This is 40, 50, 50, 40 if you want. Actually one of the angles sufficient. Now to get H1, very easy. See, consider triangle A dash D. You can write either what? I written here, see, sin 60, right? All the right angle triangles. Sin 60 equal to H1 by 120. Or you can write cos 30 also equal to H1 by 120. You can use whichever you want. You get the value of H1. Now, here, H2, see, 40 degrees, 40 degrees, 50 degrees, 50, 40. To get H2, if you can use sin 50 equal to H2 by 210. See, written here. Or you can write cos 40 equal to which one? H2 by 210. Anything, H2 will come 160.8693 millimeter. Okay, then no space, right? Algebraic sum of moments of the given force system about the point A, we will call it as sigma MA. We will take with clockwise positive equal to, put the finger at A, see, 200 into H1 clockwise plus, and about A, 450 into H2 anti-clockwise minus. H1 is known, H2 is known. It is not a high school class. Substitute H1, H2, simplify. You will get minus 51606.585 Newton millimeter. We took clockwise positive. We found the moment with the clockwise positive. Negative came. Again, problem comes later for sign convention. One class exclusively for sign convention. Therefore, answer. Right without sign. Algebraic sum of moment of the given force system about A is 51606.585 Newton millimeter. No minus sign. Clockwise you took that much. Anti-clockwise is the answer for moment about A. I write here. Answer we got. Answer by basic approach. I write here. Moment about A. Sigma M about A. See. Sigma M about A. We got how much answer? 51606.585 Newton millimeter anti-clockwise we got. Why I am writing answer? Because lastly I am going for the easy option of resolution. So at that time answer should tally. Okay, now A over. Now momentum. Now once again start. Now let us find sigma M about C. See here, C. Now C is the important point. A is not important. Therefore, this all I have to remove. I will do it now only. I will rub it here first of all. Instead of wasting time. Okay. So class, same statement. From C, draw perpendicular H1, H2. Same. That H1 is over. New H1. H1, H2 to line of action of 200 and 450 respectively. This sketch out remove now. New sketch out right. Okay. No problem. 450 now. Okay. I am saying where space required. here. It's a small sketch I will write. Space problem here. A, not important. D. Now by the force I will use red color. This force is 30 degrees. The force is 200 Newton. One more force is 40 degree angle. Yes, 450 Newton. Okay, then this angle is 30 degrees. Then this angle is 40 degrees. Our point, important point is C now. See, our point is C. So what you do? Extend this force, draw perpendicular. H1. This is not that H1, that H1 is gone. A, this is C. So I will call C dash. And here, extend this line, draw perpendicular. Okay, looks like perpendicular. H2, let it be C dash once again. Oh, there are two C, one perpendicular. Oh, okay. I think this is A, this is B. I think you should call it as C dash and C double dash. Last time I took most probably both as A dash. Okay, I'll change it. Sir, two C dash is there. So what? Okay, this I will take C dash for H1, C double dash for H2. Okay, change last time. Okay, see last time question that, no, B dash. You call B dash. This you call, what is the point here? This is A, B, C, D. Last time what I took one of them as A dash, from A dash, from C, okay, now this is I will call A dash, okay, D dash, better, okay, now no confusion, D dash, this I will call B dash, okay, now no confusion, D dash, okay, use this triangle to get H1, use this triangle to get H2. If this is 30 degrees, this is 90, this is 90, this is 60 degrees, or if this is 40 degrees, this is 90, this is 50 degrees. Start. To get H1, consider triangle D dash C. D dash C. Okay, D dash, right here, see. Sin 30 equal to sin, this is how much? This is 210, this is 120. Okay. Sin 30, this is 90 degrees. Sin 30 equal to H1 by how much? Sin 30 equal to, this is, see, this is 90, this is hypotenuse. Sin 30 equal to H1 by 210. H1 by 210. Or you can tell cos 60 equal to, if you see this angle, cos 60 equal to, again, H1 by 210. You can do whatever you want. 210. Therefore, you get the value of H1 in millimeter. At calculate. Not calculate earlier. Why? 210 sin 30 equal to 105. It is 105, round number. Why calculate? Because 210 into sin 30 is surely 105. Calculate is not on, because it is telling, do you want to calculate for 210 sin 30? 105. Okay. Now, to get H2, sin 30 is half. To get H2, triangle B dash C. B dash C. This is C. Important point. Again, see here. Sin 40 equal to H2 divided by 120. H2 divided by 120. Or cos 50 equal to, if you see here, cos 50 also equal to H2 by 120. You can use whichever you want, you can use. You will get the value of H2. 120 into sin 40. 77.1345. 77.1345. Correct answer. I should check it. I will check other way. 120 into cos 50. 77.1345 millimeter. Okay. Therefore, closing part now. I won't waste time telling same thing again and again like that. You should write. Therefore, see what I am dictating now. Algebraic sum of moment of the given force system about C, that is say sigma m about C, we will take clockwise positive equal to, see here now, clockwise, how much? 200 into H1, clockwise, plus, here, anti-clockwise, minus 450 into H2, anti-clockwise. H1 is known, H2 is known, show the calculation, get the answer. 200 into H1 is 105 minus 450 into H2. Where is H2? 77.1345. Minus 13710 minus 13. Why so such a small? 710, such a small value. Last time it was 51606, correct? Moment about C. Okay, I'll check once again. 13710.525. 0.525 Newton millimeter. I can check easily also. If you want about C, vertical component 105 into 210. Here horizontal component minus 450 into sin 40 into 120. Some other answer is coming. 200 sin 30 is 100. Oh, it is 100 actually. 100 into how much? 210. 100 into 210 minus 450 into, you don't bother about these things, into sin 40. You don't worry about sin cos all. It is my own calculation, into 120. 13710. Oh, correct. Newton millimeter. Anyway, that comes later. You don't worry. You should tell. If he murmur something in the class himself, we are not supposed to bother what he is telling. He is telling his own calculation, maybe shortcut for him, or he knows something better. He is not disclosing it. Okay, over. Therefore, conclusion, right here. Therefore, conclusion. Algebraic sum of moment of the given force system about the point C equal to 13710.525 Newton millimeter anti-clockwise. That one you got clockwise, last time you got, this is also anti-clockwise, answer. So remember, and answer is sigma m about C, we got 13710.525 Newton millimeter. This I am writing for anti-clockwise. This I am writing for checking the answer. Okay, don't see that one. Over. Now, last part, since it is so easy, I won't waste time. I will explain, no doubt, but I will write neatly because last part is resolution. That is the best option. So, I will use fresh pen and with the full shining color and full board I will write and explain to you. Because it is the most important. Now, closing part. Find same question. Now, by resolution, very important. Okay, start. Same question. Don't see here now. First, space required. I write somewhere there. Then I will rub it out. First, don't see here. See the question here. First, let us resolve the inclined forces into each force into two components, one along xx, other yy. We will call this is xx, this is yy. Actually, that also not required. Okay, start. Consider 200 Newton. Consider 200 Newton force. See, through the point D, it is acting like this. Through the point D, it is acting like this. How much force? 200 Newton. I told see the angle with horizontal 30 degrees. 30 degree given see, equal to see one component this way, one component this way to the point D, horizontal component of 200 cos 30, vertical component of 200 sin 30. This is 100 Newton. This is 173.205 Newton. Okay. Next, consider other force, 450 Newton force. 450 Newton force. It is passing to the point B. See, to the point B, somewhere here. To the point B, it is this way. 450 Newton. Both are going this way only. Okay. I told we want the angle with XX, nearest angle. This is 40 degrees, but we want this angle. Therefore, it is 50 degrees. I should not waste time on this one. So, component will be X component, Y component, 450 sin 50. This is 450 into cos 50. 450 cos 50 will be, this will be equal to 289.2544 Newton. This will be 344.720 Newton. Just checking the camera once. I have gone too much right side. Hope still space is there. No, that's the problem. I will shift the camera slightly. Further shifting required. 1 minute because it is fully clamped here. 1 minute. Now okay thing. Question you cannot see, no problem. Question 3. Question 3 also you can see. Okay. Okay. Now, over. Okay. Once this is over, then come back here. Draw a neat sketch. See, A, B, C, D. Our one important point is C, other is A. Through D, enter these two forces. I entered already here. Through B, enter these two forces. Entered here. Okay, now this is 120, this is 210. Now, very, very easy. Algebraic sum of moment. See, now both of them you can do together. Earlier, separate about A, separate because you want perpendicular from A. Then when you want about C, separate calculation. Now combined, single stretch. Take moment about A. This tomorrow, next class, I am explaining for not 4 forces, around more than 10 forces. So I will not waste time now. Tomorrow a big mega question. Tomorrow mega question comes. Mega question comes. So this is nothing. Still, hold finger at A. Start. 173. I always take horizontal first. 173.205 into 120 clockwise plus 100 kilonewton force. If you see here, passes through A, 100 into 0. Here, 289.2544 is actually passing through the point A, 0, 344.720 this way into 210, anti-clockwise. Calculate, minus 51606.6 will come. So answer is 51606.6 Newton millimeter anti-clockwise. See, yes, same. Moment about C. 173.205 into 0. I am telling you a little fast because tomorrow very, very slowly I will explain. It will be a very long class. Okay, 0. Then 100 into 210 clockwise. I wrote. Then 289.254 into 120 anti-clockwise. Yes. Then 344.720 into 0. Or remember, when you take moment about A, this force is there, this force is there, this into 0, this into 0. But when you take moment about C, what happens? This into 0, it is not there, this force is there, this force is there, this into 0, not there. So this all will be covered tomorrow in a very lengthy question, but very powerful, marathon, full board. I will put the system somewhere here, big sketch. Of course, what I will do is, to save time, the expression I will write there, but I won't see there. I will keep on telling here, you can check there. Okay. Answer will come minus 13710.528 means 13710.528 Newton millimeter, 0.525, change is not there. I will give later. Anti-clockwise is the answer. Okay, now I will conclude the class. Next class is class number 22, is really a master example, master question, and very, very important or critical for entire engineering mechanics and structural engineering. Tomorrow class I will put a heading there, most critical example for moment and entire structural engineering. Okay, that's tomorrow. Full board will be there. Thank you. Meet you in the next class.